Hello students, welcome back to Math 45, Chapter 5. We'll continue our lecture on page 24. I'm your instructor, Cindy Enrique, and we'll be going over section 5.5, which is all about the zeros of the polynomial function. So the factor theorem. According to the factor theorem, k is a zero of the function if and only if x minus k is a factor of the function. So here's an example down below. Show that x plus 2 is a factor of x cubed minus 6x squared minus x plus 30. Find the remaining factors. Use the factors to determine the zeros of the polynomials. So this first part that we want to show that x plus 2 is a factor. Well, what we know from the remainder theorem is that we can actually use a synthetic division to help us. So use synthetic division. And that's going to help us by the remainder theorem. Okay. So remember that if we have x plus 2 is equal to 0, we really have x is equal to a negative 2. So we're going to have negative 2 on the outside. And it's definitely in descending order. So we're going to have 1, negative 6, negative 1, and 30. So for that first term, I'm going to circle it and drop it down. So it's a 1. 1 times negative 2 is negative 2, and I add on the inside. So negative 6 plus negative 2 is negative 8. Negative 8 times negative 2 is a positive 16, plus a negative 1 is a positive 15. 15 times negative 2 is a negative 30. So my remainder here is 0. So the fact that my remainder is 0, then by the remainder theorem, x plus 2 is a factor. So I have just shown that x plus 2 is a factor. So now what I have is I have that x cubed minus 6x squared minus x plus 30, that can be factored. And so far, some of the factors that I have found is I have the x plus 2, and the other factor that I have found, since this is degree 3, then 1 less is going to give me degree 2. So I'm going to have 1x squared minus 8x plus 15. And I know that this can be factored further, whether you do the AC method or if you do the guess and check. If you like the AC method, that's fine. Just do the AC method over to the side. So I know that a times c here is 15. I have negative 8. So two numbers that multiply to 15 and adds to negative 8 would be a negative 3 and a negative 5. So I know that this is going to factor as x minus 3 and x minus 5. And don't forget that we had the x plus 2 as well. So now I have found the remaining factors. So now I know that my zeros are negative 2, positive 3, and positive 5. And this we can call the factors. So I found the remaining factors and I labeled them, as well as I determined the zeros and I labeled those as well. Okay. All right. So there's a lot of theorems that we're getting used to, and that's okay. We're just going to have to make sure that we use them accordingly. So the next example. Consider the function f of x. If f of x is equal to 0, for x is equal to negative 10, for what other values of x is the function equal to 0? So the fact that it's specifically telling us that it's equal to 0 when x is equal to -10, then this is specifically telling me that this is going to give me a 0. Okay, that is a factor. And it's already telling me that x is equal to -10. So I'm going to have a -10 on the outside. And I'm going to do my synthetic division, because it says what other values. So this is the same as saying find remaining factors. Okay, so I'm going to have my coefficients. So I have, let me go ahead and just write that a little bit nicer. So I have 1, I have a +5, a -44, and a +60. Okay. So now, when I drop this down, I'm going to have 1 times -10 is -10, plus 5 is -5. -5 times -10 is a +50. 50 plus -44 is 6. 6 times -10 is -60, and I have a 0. Perfect. If it wasn't a 0, then that means it wouldn't have factored. So remember, I had x cubed plus 5x squared minus 44x plus 60. And we found that when we factored, it would factor using that we have a 0. So you already know that x plus 10 was going to be a factor. And now here, since this is degree 3, then I know using synthetic division, I'm going to have it starting at degree 2. So I'm going to have a 1x squared minus 5x plus 6. And again, I can go ahead and factor that a little bit more. I can do the AC method if that's what you like. I know that a times c is 6. My b value is a -5. So that would be a -3 and a -2. So I would have x minus 3 and x minus 2. And I also have my x plus 10. So for what other values of x is this function also equal to 0? So x is equal to -10. X is equal to +3. And x is equal to a +2. So those are the other values of x that gives the function equal to 0. And remember that this x is equal to -10, that was the given. So I needed to find the x is equal to 3 and the x is equal to 2. Okay. Now we're going to learn a different theorem. This is the rational zero theorem. So the rational zero theorem states that if a polynomial has integer coefficients, then every rational zero of a function of the form p over q, where p is the factor of the constant term a naught and q is the factor of the leading coefficient a naught, when the leading coefficient is 1, the possible rational zeros are the factors of the constant term. Like, okay, like, what did I just read? Well, the most important thing to kind of take from this, I think, is that we have p is a factor of the constant term a naught. So p corresponds to a naught, where a naught is the constant. And we also have that q is a factor of the leading coefficient a naught. So q deals with an, and that's our leading coefficient. So then we know that every rational zero is going to be the form p over q. So possible zero would be my p over my q. Okay? Alright, so hopefully you understand what's going on. So this rational zeros theorem, what this is really asking us is, hey, here's another method so you can find possible zeros. Doesn't mean it's always going to work, but hey, maybe it'll help a little bit. So, okay, let's put this into play. So it specifically says to list all the possible zeros. So when it says to use all the possible zeros, then we know for a fact that we're going to be using the rational zero theorem. So remember that theorem, we have it such that f of x is equal to an to the xn plus ... plus a naught. And what's the most important thing here is that here we have the a naught that corresponds to q versus our a naught corresponds to our p. Remember, that's what we had over here, right? That p corresponds to a naught and that leading coefficient an corresponds to q. So we want to list our possible zeros as p over q. All right. So hopefully that kind of helps us to give our general form. So let's think about this. So we have the, let's say, the p value that I want to think about. So p. So the p value is going to be the very last thing that we have. So that is a -4, okay? So since we have -4, let's list out all of the different factors of -4. So I know to get to 4, that's 1 times 4 and 2 times 2. So when I list my possible values of p, it's going to be plus or minus 1, plus or minus 2, plus or minus 4. Those are all the possibilities that I have. And that plus and minus is for everything, not just the 1, but it's also plus and minus 2, plus or minus 4. Okay. So now let's deal with the q. So for q, we know in this case it's equal to 2. So the only multiples of 2 is 1 times 2. So that's going to be plus or minus 1, plus or minus 2. So now what we do is we take all the possibilities of p and we're going to divide them by q. So we know that we have plus or minus 1 over, let's say, my q value of 1. All right. Now I have a plus or minus 1 over my plus or minus 2. Okay. I also have plus or minus 2 over 1. And I also have my plus or minus 2 over my 2. And I have my plus or minus 4 over my 1. And I also have my plus or minus 4 over my 2. So notice how up on top my numerators are those different choices of 1, 2, and 4. Versus the bottom, the denominator, my different choices are 1 and 2. So 1 and 2, 1 and 2, 1 and 2. So let's simplify this a little bit. So this first one is going to be plus or minus 1. I have plus or minus 1/2, plus or minus 2. This actually reduces to 1, but we already have 1, so that's checked off. We also have plus or minus 4. And 4 divided by 2, that reduces to 2, but we already have 2. So we don't really keep those extras, okay? So now we have our different possibilities of zeros. So possible zeros. So we have 1, -1, 1/2, -1/2. 2, -2, 4, and -4. So all of those are going to be all the possible zeros for that function. Doesn't mean that all of them are going to be it. It just means that those are all the possible zeros that we have. Okay, so we're going to take that idea and we're going to use that to find the actual rational zeros of this function. So it says use a rational zero theorem to find the rational zeros of this function. So again, let's look at our p-value. So my p-value is equal to 1. So p, I'm going to think about it as just plus or minus 1. And that's it. That's the only thing I have. So then my q is going to be 2. So that's going to be plus or minus 1, plus or minus 2, since those are the only multiples of 2. So now when I do my p divided by q, I'm going to have 1 divided by 1. I'm also going to have 1 divided by 2. And don't forget that this is all my plus or minus. So really the possibilities, I have 1, -1, 1/2, and a -1/2. So I have 4 total possibilities. So I'm going to go ahead and try these 4 possibilities. Now, so to actually find my zeros, there are 2 things you can do. You can either do the synthetic division, or you can just plug in values directly. And it's really just up to you. Do you feel more comfortable with synthetic division, or do you feel more comfortable plugging in the values directly? For me, I actually like plugging in the values directly. So I know, so let's say I'm going to use method number 2, because that's what I feel more comfortable with. So then I know that for my function f of x, I had this 2x cubed plus x squared minus 4x plus 1. And that was my original function. So here are the possibilities. So I'm going to try to plug in x is equal to 1, since that's one of my possibilities. So f of 1, when I plug it in, I get 0. That's amazing. When I plug 1 into this function, I get a 0. So I specifically know that I have a zeros. So zeros. I have that x is equal to 1. It's definitely going to be a 0. Now let's try some of the others. Let's say now I try my x is equal to a -1. So f, now I'm going to plug in my -1 into my function. When I plug in -1 into my function, so 2 times -1 to the third plus -1 squared minus 4 times -1 plus 1. So remember, here I'm using my calculator. And when I plug that in and get that -1, I get a positive 4. So that means, nope, this is not going to be a 0. That's okay, I keep going. So I have a couple of more possibilities. I have x is equal to a positive 1/2. So f of 1/2. Let's see what happens when I plug that in. So when I plug in that 0.5, now I'm actually going to need my calculator. So I have 2 parentheses. And I can use a 0.5, that's fine. And I have a plus, and I have a 0.5 squared minus 4 times 0.5 plus 1. And I end up getting a negative 0.5. So that is not a 0 as well. So that's fine. I keep going. So now I'm going to try a different value. So now let's try x is equal to a negative 1/2. So f of a negative 1/2. Let's see when I plug that in what happens. So 2 times a negative 0.5 to the third power plus negative 0.5 squared minus 4 times a negative 0.5 plus 1, and I end up getting a positive 3. So that is also not a 0. So it looks like the only 0 that worked was going to be my x is equal to 1. This is the only one that was a 0. So x is equal to 1 is my only rational 0 that I'm going to find. Okay? So that's kind of the whole picture there for the rational zeros theorem. Okay? All right, next page. So for page 26, what we're thinking about now is the fundamental theorem of algebra. So for this one, we are still finding our zeros. The only difference now is that they can be complex numbers. So that's what our fundamental theorem is going to be saying here, okay? So we are finding our zeros that may be complex. Which is I. So that's what our theorem is talking about. So, okay, let's see how we do this. So again, we're going to go with the P and the Q here. So we have the 0. So it says find the zeros of this function. So, okay, fine. So I know that my P is always going to be the last term. So P is equal to 3. So I'm going to be thinking about plus or minus 1 and plus or minus 3. And the other one that I have is Q. Q is equal to 3 as well. So I have plus or minus 1, plus or minus 3. So then my P over Q is going to be, and here are all of my values, so I'm going to take my P, so it's going to be 1, and I'm going to divide it by my Q value. So I'm going to take my P value, and I'm divide it by my Q, which is 3. So I used 1, so that one's used up. So now I'm going to be using my 3. So 3 divided by my 1, and I also have my 3 divided by my 3. Okay, so now I've used 3 up in the numerator as well. So really my P over Q is equal to plus or minus, and we have 1. We have plus or minus 1/3, plus or minus 3, and we know that 3 divided by 3, that reduces to 1, but we already had 1. So really, we only have 3 different possibilities, or actually 6, right? Because this is 1, negative 1, 1/3, negative 1/3, 3, and negative 3. So these are going to be our different possibilities. So we have 6 total possible zeros. Possible rational zeros. Okay. Alright. So, I don't know. Maybe we would try that x is equal to, let's say, our negative 3. So if we try here, so remember, the ways that we can do this is by doing synthetic division or plugging in the values. I'm going to plug in values. So plug in x values. Okay, so I'm going to try that x is equal to positive 1. Okay, so I'm going to have f of 1. So I'm going to plug 1 into my function. And remember, that function here that I'm plugging into is my 3x cubed plus 9x squared plus x plus 3. So I'm going to plug a 1 into all of that. So here I go, onto my calculator. Hopefully you're plugging this into your calculator. 3 times 1 to the 3rd power plus 9 times 1 squared plus 1 plus 3. Now I'm going to get a positive 16. So this tells me that this is not a 0. So that's fine. So I'm going to try the next one. Let's try x is equal to negative 1. So f of negative 1. So I tried positive 1. That didn't work. So f of negative 1. Let's try that. So 3 times negative 1 to the 3rd power plus 9 times negative 1 squared plus negative 1 plus 3. This is going to give me 8. So negative 1 didn't work as well. She was like, okay, well, the 1/3 are going to be kind of difficult, but that's okay. And I don't have to go in order. So let's say I want to try 3 next. So let's try 3. So x is equal to 3. So f of 3. So, okay, 3 times 3 to the 3rd power plus 9 to the 3 squared plus 3 plus 3. And that gives me something very huge. That's going to give me 168. So positive 3 didn't work either. So, okay, let's try x is equal to negative 3. So remember, I'm trying all of these possibilities. So let's see what f of negative 3 is going to give me. So when I plug it in, so 3 times negative 3 to the 3rd power plus 9 times negative 3, which is squared, plus negative 3 plus 3. Ooh, that's exciting. I get this to be a 0. When it says 0, that makes me happy because that means I actually found something here. So negative 3 is definitely going to be a 0. Well, that's fantastic. So now I know that this 3x cubed plus 9x squared plus x plus 3 is going to factor. And I want to know exactly what the factors are going to be. So, since I already know that negative 3 is going to be a 0, I'm just going to do my synthetic division. I'm going to see what I get. So remember, I have 3, 9, 1, and 3. So when I bring that down, I'm going to have a negative 9, which is a 0. That's 1. So when I rewrite this, I'm going to have this as 3x squared plus 0x plus 1x. So that's one of the factors that I have. And don't forget that I already knew that x is equal to negative 3 is also a 0, so x plus 3 is also a binomial factor. So all of this is equal to 0. So now I know that 3x squared plus 1x is equal to 0. So if I were to factor that out a little bit, I have an x, and I'm going to have 3x plus 1 is equal to 0. So x is equal to 0, and 3x plus 1 is equal to 0. So 3x is equal to a negative 1, and x is equal to a negative 1/3. Sorry guys, I did a small error, and that's okay, sometimes that happens. I just don't want to remake my video because I'm already about 30 minutes in. But notice here how I have a 3x squared, a 0x. That should have been my constant. So I apologize, I kind of did this work wrong. And that's okay. Let's just go back. Rewind. I do apologize. I rewrote this slightly wrong. This should have been a 3x squared plus 0x plus 1. There we go. So I should have had 3x squared plus 1 is equal to 0. And I also have my x plus 3 is equal to 0. So x is equal to a negative 3. So for my other one, I have 3x squared is equal to a negative 1. So x squared is equal to a negative 1/3. To get rid of the square, I'm going to square root it, but don't forget the plus or minus. So I get that x is equal to plus or minus the square root of a negative 1/3. So I have the following zeros. X is equal to negative 3. X is equal to I square root 1/3. And x is equal to a negative I square root 1/3. So here are the zeros that I need. Okay? And the reason that it became I is because it's negative on the inside. So if it's a negative inside the square root, then that means that it's going to be an imaginary number. So I have I square root 1/3 and negative I square root 1/3. And I do apologize there, I had a small typo. But at least I can go back and check all of my work. Okay, so let's go on to the next page. So we have the complex conjugate theorem. So here, according to the linear factorization theorem, a polynomial function will have the same number of factors as its degree, and each factor will be in the form x minus c, where c is a complex number. If a polynomial function f has real coefficients and a complex zero in the form a plus bi, then the complex conjugate of 0, a minus bi, is also a 0. And you're just like, okay, well that's cool. So I know that if I were to have a plus bi, which is complex, and we know it to be a 0, then we also know that the conjugate a minus bi is also going to be a 0. I'm like, okay, well that can help us. And of course we know that if a polynomial has degree 4, then it should have 4 factors. So it says, find a 4th degree polynomial with real coefficients that have zeros negative 3, 2, and I, such that f of negative 2 is equal to 100. So, okay, so the fact that it says a 4th degree polynomial, so that tells me that my degree, n, should equal to 4. So I should have about 4 factors here. So here, let's look at our zeros that I have. I should have 4 zeros. Since my n is degree 4, I have 1, 2, 3 zeros. But remember from the complex conjugate theorem, if I have positive I, then negative I should also be a 0 as well. So I know my general term of my function. So function f of x. And you don't know that leading coefficient, so let's call it a. So a is going to get multiplied. So let's think of our zeros here. So I have x, my 0 is negative 3, so I have an x plus 3. My 0 is 2, so I'm going to have an x minus a 2. Now I have my complex zeros. So my complex zeros, I have x, and since it's a positive I, then it's minus I, and since it's a negative I, it's the opposite sign, so plus I. Okay, and the reason I wanted that space there is so that way I can multiply my real numbers, and I can multiply my conjugate numbers as well. So I'm going to rewrite this, and it's going to get a little messy before I clean it up, and that's okay. So I am going to make sure that I go ahead and I FOIL this out. So when I FOIL this out, I'm going to have x squared minus 2x plus 3x minus 6. And it's going to get multiplied. And over here, I'm going to FOIL this out. So I'd have an x squared plus I x minus I x minus an I squared. So then my f of x is equal to my a still. Now I'm going to simplify the inside, so I have an x squared plus x minus 6. And over on this side, since there were conjugate terms, the plus ix and the negative ix cancel out. So I have an x squared minus, and remember that I squared is really negative 1. So I have a minus negative 1. So f of x is equal to my a value, and I have x squared plus x minus 6 and here, if I do this over to the side, I have this x squared minus negative 1. It's really x squared plus 1. So I have an x squared plus 1. That's going to get multiplied. So I'm going to have a. And now I'm going to multiply. So I'm going to multiply this trinomial by this binomial. And if you like to do the chart method, that's fine, or the box method, or if you like to distribute, that's fine. If you're like, wait, what's the box method? Don't forget the box method you can do over in your scratch work. I can have my x squared, my positive x, and my minus 6. And going down, I have an x squared and a positive 1. And this is just to help me organize on how I'm multiplying everything together. So here I would have an x to the 4, I have an x to the 3, and a negative 6x squared. Here I have an x squared, I have a x, and I have a negative 6. So I would have an x to the 4, a positive x to the 3, and I can actually combine this x squared and that negative 6x squared. So negative 6 plus 1 would give me a negative 5x squared plus x minus 6. Okay. And this is, of course, my f of x. Okay. So now that I have that very long polynomial, I also have one piece of information that I haven't used yet. That piece of information is that f of negative 2 is equal to 100. Well, this tells me that x is equal to negative 2, then my y is equal to 100. So I'm going to plug that into my equation. So my y value is 100. It's equal to a. Now I know I have, what I'm plugging in for my x value is a negative 2. So negative 2 to the 4th plus negative 2 cubed minus 5 times negative 2 squared plus negative 2 minus 6. I'm going to plug all of that into my calculator. Now I'm going to get a negative 20. So really I have that 100 is equal to negative 20 times a. To get the a by itself, I'm going to divide by negative 20. So 100 divided by a negative 20 gives me a negative 5, which is equal to my a value. So now I have that a value. So now I'm good. Now I know that f of x is equal to negative 5. And now I have my x to the 4 plus x to the 3 minus 5x squared plus x minus 6. And the very last thing that I need to do here is to distribute. So that I can get f of x is equal to a negative 5x to the 4 minus 5x to the 3 plus 25x squared minus 5x plus 30. Since I multiplied everything by a negative 5. And that ends up becoming my final answer. Okay. So this is all because I have a 4th degree polynomial. So it's definitely degree 4. And I had my zeros, and I had my 4 different zeros. I was also given the ordered pair, negative 2, 100. So I needed to plug in x is equal to negative 2, and I needed to plug in my y is equal to 100. Okay. So the next thing that we're going to have is our Descartes rule of signs. So for the Descartes rule of signs, the number of positive real zeros is either equal to the number of sign changes in f of x, or is less than the number of sign changes by an even integer. The number of negative real zeros is either equal to the number of sign changes of f of negative x, or is less than the number of sign changes by an even number. And you're just like, okay, like what the heck is this saying? Well, we know that this is Descartes' rule of signs. So signs means we're going to be dealing with the plus or negatives, okay? So we want to know the possible numbers of positive and negative real zeros according to Descartes' rule of signs. So let's deal with the positive real zeros first. So for my positive real zeros, let's take our original function f of x. So it says specifically, for positive real zeros, it's equal to the number of sign changes in f of x. So it's just our regular function that we have. So it's a negative x to the 4 minus 3x cubed plus 6x squared minus 4x minus 12. So I have not changed anything. The only thing I did was write out my f of x function, my original function. I'm going to count how many times it changes. So by changes, meaning from like negative to positive or positive to negative. So negative to negative, no sign change. Negative to positive, ooh, the sign change. Positive to negative, that's an opposite, that changed. Negative to negative, that did not change. So I have a total of 2 sign changes. Because that is true, then we have, by Descartes' rule of sign, so by Descartes' rule of signs, we have either 2 or, and it says or less than the number of sign changes by an even integer. So what's 2 minus 2? 0. So we either have 2 or 0 positive real roots. All right. So now the next thing we're going to look at is we're going to look at the negative real zeros. So for the negative real zeros, this is slightly different, and it specifically says the sign changes of f of x. Okay. So that means we're going to plug negative x into x. So, okay, let's think about this. So I have my original function f of x. That was that negative x to the 4 minus 3x cubed plus 6x squared minus 4x minus 12. That's what we originally had. So now, when it specifically says f, instead of x, I'm going to plug in a negative x. Okay, that's weird, but just go with it. So negative to the 4 minus 3 to the 3 plus 6. And it's really helpful just to put parentheses around everything that you're going to be plugging in. So I'm going to be plugging in negative x, negative x, negative x, negative x. So this is going to give me a new function. So then f of negative x is going to give me, and you got to think about this, negative times negative times a negative times a negative. So negative x to the 4 is positive. So I'm going to have a positive x to the 4 and a negative on the outside. So negative x to the 4. Now here, a negative to the 3rd power is negative, and I have a negative 3 that's being multiplied, so a negative times a negative is a positive. So positive 3x to the 4. Now here I have negative x squared, so that's going to be a positive 6x squared. And I have negative 4 times negative x, so that's a positive 4x minus 12. So now I have f of negative x. So now I can count my sign changes. So from here to here, negative to a positive, it changed the signs. Positive to positive, leave it alone. Positive to positive, leave it alone. Positive to negative, ooh, the sign changed. So that's 2. Okay, so that means 2 sign changes, either from negative to positive or positive to negative. So then by Descartes, and it's 2 or, and it says or is less than the number of sign changes by an even integer. So again, so it's by an even integer, 2 minus 2 is 0. So 2 or 0, negative real roots. So that is going to be my final answer there. Okay. So 2 sign changes means we either have 2 or 0 negative real roots. Okay. Well, I hope that makes sense. If not, you guys can always email me or go to the Max Success Center or get a tutor. And for this last problem, I actually don't like it very much, so I'm not going to go over it. So I do apologize that it's an extra page there. So again, please contact me if you guys have any questions. I'm here for you. Okay, thank you for listening. And that's the end of section 5.5.